it's time to get started. As systems continue to modernize and evolve, so does the risk landscape that impacts those systems. And many security issues are challenging to discover and to patch them quickly. And it's affecting both the application and the system functionality. And additionally, certain security issues can be tricky to uncover during the development phase. My name is Gunnar Grosch. I am a developer advocate at AWS. And in this session, we're going to explore how you can use experimentation and failure to identify potential vulnerabilities. And I want you to learn how we can make use of practices that we do for system resilience to verify your system's security posture and perhaps develop a bit more proactive approach to security. And who doesn't love a short agenda? We are starting off by looking at chaos engineering and what that practice is before switching over to security chaos engineering, and then spending a big part of the session actually looking at it in practice, how to do it. So, traditionally, organizations have been forced into a binary trade-off. Either move quickly or stay secure. And due to many of the manual security processes, InfoSec has often been forced to slow things down to human speed to ensure the security of the organization or the system. Today, with the cloud, it is of course possible to automate many of the basic security tasks, such as patching and so on. And with the right tooling, you can gain the visibility needed into your system to identify and monitor these critical assets and data. And with the cloud, it is of course a lot easier to do this because you can stay agile while maintaining and in many cases even improving security, of course. So by providing these highly integrated logging, monitoring, and security services, you can then automate and make many of these core security functions in a way that makes it easier for you to still work fast, move fast, and stay secure. And I'm sure you're going to see this one many times today. I just want to touch on it. Even Paul mentioned it in his keynote, that we, of course, work with this shared responsibility model where we at AWS, we look after the security of the cloud, and the customers look after the security in the cloud. So our responsibility is security of the cloud. And for the customer then, the security in the cloud means that it depends on the AWS cloud services that you actually use, what type of security measures you need to put into place. It also then determines the amount of work you need to put in to make sure that your services are as secure as possible. And we have a similar model when we talk about system resilience, a shared responsibility model where we share the responsibility between AWS and the customer. And when we're talking about system resilience, we don't want to wait to learn and find out if our system is resilient to failure. And here, for security, we don't want to wait to know if we have a good security posture. I don't want to wake up in the middle of the night to an alert telling me that something has gone wrong. And just like I want to know if my highly available database cluster is actually working the way I intended it to be, that it is resilient to failure, we want to know that we have a strong security posture when that web exploit strikes or when someone tries to gain unauthorized access. We want to know that in advance. And for resilience then, well, we have this practice called chaos engineering that helps us do just that. It helps us build confidence in the system, in how resilient to failure our system is. And chaos engineering then, it is the process of stressing an application, either in production or mainly perhaps in pre-production environment, by creating different types of disruptive events. And with these disruptive events, we then observe how the system responds to these events. And then finally, we implement our improvements on the system. And these could be improvements to the system's resilience, to how the high availability works, our monitoring, our alerting, and so on. And we do all of this to prove or disprove our assumptions about the system's capability to handle any of these disruptive events. But instead of letting them happen in the middle of the night or during the weekend, we can do this in a very controlled environment and during working hours, when the engineers are there to actually see and fix those issues. And one very important goal with chaos engineering is to increase our confidence in the system, how resilient the system is to failure. And when we do chaos engineering, it's very important to understand that it is not about breaking things randomly without any purpose. No, chaos engineering is about breaking things, but in a very, through these well-planned experiments, where we then use to build confidence, like I said. And we do it in a way that is very scientific in nature. And we follow this well-defined process, and it takes us from first understanding the steady state of our system. What does the system normally look like under normal circumstances? To then articulating a hypothesis about the system. What if my highly available database cluster has an issue? What happens then? We form a hypothesis. If this happens, then that should happen. Around that hypothesis, we then create an experiment, often using fault injection when we're talking about resilience. We take down the primary database instance to see what our hypothesis actually looks like. We then verify the results of that experiment that we're doing by looking at the steady state, comparing it to our experiment. And then finally, we improve our system. So we learn from that experiment and improve the system's resilience to failure. But it could also be the system's performance. It could be the monitoring, it could be the alarms, basically the overall system. And at AWS, we today have many customers doing chaos engineering, but something that we heard over and over again is that it can be hard to get started with. So we now, for I guess it's 2.5 years ago, we launched our managed service for chaos engineering called AWS Fault Injection Simulator. And it's a service that is meant to make it easier for customers to do chaos engineering experiments in a very safe and controlled manner. It embraces the idea of something we call safeguards, which is a way to basically monitor how big the experiment or the impact of the experiment can be, and then stop it if it sets up alarms, for instance. And I'm going to be using Fault Injection Simulator in a couple of demos in a while, so I'm going to show you the basic components of it so you know what those mean. We, first off, have what we call actions. And that is the fault injection activity that we want to run in our experiment. And that could, for instance, be stopping an EC2 instance or adding latency, for instance. Then we have a target, and a target could be one or multiple AWS resources within your cloud environment. And these could be selected, one specific, or it could be using filtering. So choose only the ones that have this tag or that are in this specific state. And we create what we call experiment templates, which then include both the actions and the targets, and also any stop conditions that we might want to have, that is, the alarms to monitor the experiment. And then finally, we use our experiment template to run the experiments. And with the experiments, we're then able to follow that process that I showed you, the flywheel, to learn from the experiments in the end. All right, so now you all know what chaos engineering is and the benefits of chaos engineering. So how do we then make use of this knowledge in security? So we move on from chaos engineering into security chaos engineering. Well, the practice is still the same. We still lean on these same principles, the principles of chaos engineering, and that very scientific method of experimentation. So we can go back to this earlier definition, and in a very overly simplified way, we can then tack on security to it. So we now have security chaos engineering. But instead of stressing an application by creating disruptive events that are focusing on resilience, we're now going to focus on security-related events. So going back to the flywheel, well, there's no real difference. We're still going to follow this well-defined scientific process. It's just that the steady state in this case is going to be the security posture. So looking at the tools, the insights we have around security, for instance, using Security Hub or Guard Duty and so on. And looking at the hypothesis, well, that's going to focus on security. And then finally, our experiments, they are security-related experiments. So I'm just going to show you a few examples of experiments that you could do. And just to point it out, I mentioned it briefly before, this isn't something you should start off with in your production environment. You can try these out in pre-prod, in testing, and so on before moving it away from there. So one example is, for instance, making an Amazon S3 bucket public. Many have automated remediation in place to make sure that S3 buckets aren't public. But now you can create these experiments and do that and see, does that remediation actually work, your automation that you have in place. You could open an unapproved port in a security group. For instance, open SSH access into servers. You could run crypto mining on an instance and see if you're able to pick that up. You could make unapproved policy changes to your IAM policies or S3 bucket policies. You could perform port scanning on instances. You could run brute force. You could do a lot more. So think about these what-if questions that I mentioned before, looking at the flywheel. What if this happens in my environment? Will I be able to pick that up? And, well, the learnings from this could be, are we permitted to do this? Or, what happened now? Well, this is chaos engineering. So I guess we'll have to test my hypothesis. All right, so with this, we can then try doing these experiments, and we can then learn from them. Like I mentioned, are we permitted to do this? Is the experiment detected? Is often a very important thing around security. Does anyone respond? PowerPoint is living its own life. Does anyone respond to the incident? And does it get automatically remediated? So let's put this into practice and then see a couple of examples of how to do this. And I mentioned RDP brute force. So let's look at that as our first example. And now, looking at the flywheel, we, of course, already have a clear view of our steady state. Our organization has insights into everything, so we can skip that part and look at the more practical part of it. So the first thing we want to do is create our hypothesis. And the hypothesis is basically based on the question, what if we have an RDP brute force attack? Well, if an instance has been used to perform RDP brute force, it will then be observed by Guard Duty in this case, and remediation will be performed. And that could be some sort of automation around isolating the instance, or it could be simply alerting our InfoSec team, or whatever remediation we might have in place. The experiment design in this case will be using an action that is making use of SSM, integration into SSM. So we have an SSM document that is basically being pushed to an EC2 instance that then has some actions in it to run RDP brute force against another instance. And we're then going to target one of our EC2 instances with this. So let's try it out. what we see right now is the AWS Fault Injection Simulator console. So we're going to do all of these experiments in the console. Switching over to the EC2 console to make sure we have 3 instances in place, we're going to make use of the blue one and red one instance in this case. So the first thing we want to do is create our experiment template. I'm giving it a name, calling it RDP brute force, adding both description and name in this case. And the next step then is to add the action that we talked about. And an action, it could be a single one, or we could have multiple actions in one template that are run either in sequence or in parallel. In this case, we're just going to have one. And like I mentioned, we're going to make use of an SSM integration. So I'm choosing the one called SSM send command, which sends a command to the EC2 instance and running a certain document. Then I'll simply refer to my document using the ARN, so pasting that into the field. And in this specific document, I need to add some parameters. The parameters in this case is which host am I going to target. So I'm adding an IP address to a target instance. I'm then adding a duration of 5 minutes. So saving that. And then adding my target, which EC2 instance basically is going to do this for me. So we can edit the target. And like I mentioned, we could either specify one specific instance in this case, or we could make use of tags and filters and so on to randomly select one or multiple instances. I'm selecting the red one instance and saving that. This is, of course, secure, so we need to select the IAM role that allows us to run this experiment. And I have a pre-prepared role. And the next section is the stop conditions that I mentioned before. We're skipping that in this demo, but stop conditions is, of course, something we should use for our experiments. I'm creating the template. And now with that template set, I can run the experiment. So we're starting our experiment. And it's then going to do the actions that I've added. It asks me to confirm because these actions are actually happening. It's not a simulation, even though the name could suggest so. All right, so this is now initiating, and in a few seconds, it's going to start performing these actions for me. So the experiment is now running, and a few seconds later, it will also start running the actual command. There we see that. Switching over to SSM, just to make sure, we can see that we have a command that is happening now. And like I mentioned, this means that the red one is performing the actions that we said, which are to send RDP brute force against the other instance. And what we want to do here is to verify that our security measures are in place. It has now done this very fast, quick 5 minutes, and we can then check the results of our experiment. So if I switch over to guard duty, we can see that guard duty has now a finding in place. So it has detected that this instance is performing RDC brute force attacks against another instance. And with these findings in place, we can then make use of any automation or alerting that we want, of course. We can also see that this shows up in Security Hub as a finding from guard duty as well. And with those findings in place, we can then verify our experiment. And in this case, well, the experiment was basically making sure that our systems are able to pick up that we do have an RDP brute force attack. In a few seconds, it would likely also pick up the other one, that this instance is being attacked by an RDP brute force attack as well. So that's our first experiment, showing how we can make use of chaos engineering as a way to test and verify the security posture of our application. So next, I want to show an example of security groups and when for instance, someone by mistake or on purpose gives public access in a security group. And in this case, we then start off in the same way. We have the steady state, we know what our system looks like, so we form our hypothesis. And the hypothesis in this case is, if public access is granted in a security group, the configuration change will be picked up and remediated. Because in this case, in our environment, we have automation in place that is, with the help of AWS config, scanning for these rules, with the help of rules, scanning our security groups to pick up on public access. And the experiment design in this case is to make use of another SSM feature using the start automation execution, and then we have a specific document for that as well. So instead of like the previous one where we sent the command to an EC2 instance to do RDP brute forcing, in this case we're using automation that doesn't rely on a single instance to do the changes of the security group. All right, and we're targeting one security group. And see if it's starting. We're back in FIS, showing you our security group. If we take a look at that one, we can see that it has two rules in place right now. Those are for RDP in this case, so 3389, and two specific IP addresses or sources. So those are fine right now. But we then have a config rule in place that checks for public access. And if it finds a resource that is then in scope for this rule, it will show up. And we're making use of Event Bridge to basically start off a Lambda function to then revert that change. So if a security group has public access, config picks it up, sends an event through Event Bridge, starts a Lambda function that removes that public access. So automation for remediation. All right, so then back to AWS Fault Injection Simulator to create our experiment template. Quickly running through the same steps, adding a description and a name. And then adding our action. Calling it open SHS, SSH, using start automation and adding my document. So this is a predefined SSM document. Pasting that. And then once again, I need to add certain parameters. And the parameters in this case is choosing which security group I want to target. So I'm pasting that in JSON and then simply adding the name of the security group. Setting a duration of 5 minutes and saving. And like I said, in this case, we don't define a target because it's not an EC2 instance that would run it, so we can skip that. We need to still select our IAM role that allows us to run this, of course, and then we can create the template and save it. There we go. All right, almost done. Starting our experiment. And once again, confirming that we want to start the experiment. And it will now do those quick actions for us. So updating our security group, first off, allowing public access. So let's see in a few seconds. It's running. And checking our security groups. We can see that it is very soon adding public access on port 22. And that is then, hopefully, if everything works as we expected, picked up by config. It is as non-compliant. And with that rule, well, it will then do the remediation that we have defined before, our automation. So it kicks off our Lambda function. The Lambda function says no, no, and removes that public access. And with that, let's update it quickly. The port is removed. We have verified through our experiment that it actually works as we intended to, and we can then see that, yes, we have automation in place. We have verified the security posture for this particular case. All right, so that was the second experiment. If you want to learn more about security chaos engineering, go to the link, grosch.link/SCE, or scan the QR code. I will, of course, be around all day, so if you have any questions, reach out to me. And with that, if people have scanned, I will move on. Oh, I can just say thank you here. So thank you, everyone, for joining this session where we looked at security chaos engineering. Thank you all very much.